Do you know if JavaScript has types? Well, the answer may surprise you. Welcome to another episode of Too Long to Read TypeScript. Today I will show you what kinds of types we have in TypeScript and how you can build your own. But first, let's address the elephant in the room, shall we? Hello friends, it's Nikos here, and today I have another interesting topic to discuss with you. So I want you to remember this thing. I don't know, put it like a sticker or post it somewhere. In JavaScript, variables don't have types. Their values have types. Let me show you exactly what I mean. So I'm here in my terminal and I will simply run Node.js. So you can run this in a browser if you want, the result will be the same. Usually we define variables like this, var a equals hello, but in JavaScript you can actually omit this part, and this is a totally valid expression. So if I run this just returns a string. This is a little bit strange for other programming languages, but for programming languages like JavaScript, this works perfectly fine. In a similar way, I can have 2021, which is the year that we have, or I can have, for example, an array of numbers, that's the array. I can also say dot length, and yeah, this works perfectly fine. I get back 3. So let's try to create a variable, let's say year, and let's assign the current year, 2021. Okay, this returns undefined, but it works. So if I call year, I will get back 2021, which is exactly what I want. So here's where the things go a little bit weird. If I try to change the year to a string, this perfectly works fine. And you can see that this used to be a number because it doesn't have the quotes. And this is a string now because it has the quotes. If you want to be 100% sure, you can say type of year and you will get back string. This is not the type that the year has started with, right? Because before the year was a number and now the year is a string. So as you can see, variables in JavaScript don't have a specific type. So it can be anywhere basically. But the values, as we saw, have type. So if I say, for example, type of 221, I get back a number. If I say type of 2021 as a string, I get back a string. The situation gets a little bit more weird if we try to calculate things. So for example, I would expect that 2001 plus 1 equals 2022, right? But if I try to say year plus 1, I will get a concatenated string because it coerces automatically the number 1 to a string, and then it concatenates these two strings to this weird number. So sometimes this doesn't have the best results. If I try, for example, to say that year is 2022, if I try to type the year with words and then try to multiply year by 2, I get not a number because JavaScript doesn't know what to do with this string, right? The situation gets a little bit more weird if I say type of not a number, which is a number. What a total disappointment, right? Nobody can trust such a language, and yet so many applications are written in JavaScript these days. So, just to recap what we've learned, variables in JavaScript don't have types, but the values have types. So what kind of types we have available? Well, first of all, we have, as we've seen, numbers, strings, then we have booleans, of course. So if I'm here, I can simply say true, and this will be true. So this is another type. We also have undefined. This is basically when you declare a variable, let's say variable b, without specifying any value. So the type of this variable, type of b, will be undefined. There is another type which is null. So if you declare another variable, let's say variable c that equals null, it returns undefined, but if I check c, this will be null. And remember that null is not equal with undefined. All these variables that we've seen so far are called primitive types because they are immutable values, which means every time that you assign a new value or create a new value, they basically destroy their previous values. They don't update the existing values. Everything else, every other variable in JavaScript is an object, including arrays or dates or everything. So these are reference types, and these are not immutable. They are mutable, and we call them reference types because you don't store the actual contents of these values. You just store a reference. When you pass the object around, you pass the reference. Let's create an object. For example, we can have artist, and the artist can have a name. Of course, we don't get back anything, but if I call the artist, you can see its contents, and if I specifically get the name of the artist, I get back Pink Floyd. Of course, I can go back and change this variable to whatever I want. So one last thing that you need to know about JavaScript is that we can have global variables too. So for example, we can have a var x equals something, but we can completely omit the keyword var, and this will actually create a global variable, which means that x will be available everywhere in our project. Okay, and after this short recap of types in JS, it's time to check how many types we have in TypeScript. This is where the things get a little bit more interesting. So I'm going back to my text editor. I have an index.ts file, which is a completely new file. And here, let's try the same example as before. So I have a var year, which is 2021. Perfect. Now what I will try to do is to change the type of the year to 2021 as a string. And as you can see immediately, TypeScript has prevented me from changing this. It says type string is not assignable to type number. This is pretty much what we expect. But as you may notice, I didn't define the type of the variable year. TypeScript has automatically understood that this variable is now a number because I assigned a number in the first place. This feature of TypeScript is called type inference. It is also called right-hand typing, which is basically refers to the right-hand side of this assignment here. Obviously, as you may have guessed, there is also left-hand typing, which is the part before the equal sign. So here, for example, I can specifically say that this is a string and it will always be a string. So if I convert this to a string, it will work perfectly fine. This also allows me to completely remove this assignment here. So this here variable is currently undefined, and actually TypeScript will also prevent me from using it in my code. Take a look at this. I tried to console log the contents of the year, and I get back that variable here is used before being assigned. So I have to move this line right after I assign it, and then it will work perfectly fine. Also, you will notice that as I move my mouse on top of this variable year, I can perfectly see that it's a string. So let's see what kind of types we have in TypeScript. So first we have strings. We can have, for example, the title of a song. Then we can have numbers. We can also have Boolean values. For example, is favorite. As you guessed, we can also have arrays. It's an array of strings. Similar to JavaScript, we can have undefined or null. There are also other special types like void. For example, if your function init doesn't return any value, so you can say it's a void. These are basically the most important types that you will use on a daily basis in your applications. Types are great, right? I know. So now there are situations that you need to temporarily make the type system less strict, or you want to disable the type checking just for a while, just to work with some third-party library or with some legacy code that you have. So you cannot just rewrite everything from scratch, right? You cannot just have types everywhere, especially if you have a large project already written in JavaScript. So what you can do is gradually introduce types in some small parts of your application until you have the whole application written in types. One of the keywords that most of the developers hate is called any, and let me show you how it works. So basically I have, let's say, a new variable year, similar as before, but now I will set it as any. So this variable can start being a number, and then I can change the type to a string. As you can see, TypeScript doesn't complain at all, because this basically tells TypeScript that year can have any type. This works exactly like JavaScript. So type checking is disabled. Now you may ask me, is this even legal? That's why we added TypeScript, right? To introduce types. Why now we need to disable them? So sometimes, for example, I want to try something quickly just to see if it will work, and I don't want to mess with the type system. So I use any, and then I console log it to the terminal, and then after I see that it works, then I can go back and introduce all the types. So basically my team never knows that I'm using any, right? This is actually what any does. It's like a wildcard. You can use it, but use it with caution. There's also a setting in your TypeScript configuration to completely disable this feature, so that you don't allow anyone to use any in their code. Now there is another way that you can completely disable TypeScript errors. Let's say that you have a variable minutes, which is 20, and let's try to assign a string to a minutes. So basically, we can disable the errors of TypeScript for specific lines. So I can go here, I start a comment, I put the @ and boom. These are some special kind of comment types that you can, annotations that you can put in your code. tsignore will suppress any TypeScript errors for the next line. So as you can see, TypeScript is not complaining anymore about minutes. Although it's a number, I was able to assign a string to it. Now there is another wildcard that we use in TypeScript quite a lot, which is named unknown. Let me show you what is the difference. So I create a new variable duration, which is unknown. Similar to any, I can assign pretty much anything that I want in this variable. So I can assign, for example, a number. I can also assign the duration in minutes. And as you can see, nothing will break. TypeScript will not complain. It was pretty similar to any. But here's where the good part starts. So if I had another variable, let's say duration in minutes, which is a string. So currently my duration is a string. So let's try to assign it into duration in minutes. So duration in minutes equals duration. If I use any, for example, this will work just fine because any doesn't have any type checking whatsoever. But if this is unknown, there is a very interesting thing going on here. So duration in minutes, basically it's a string, and you cannot assign unknown variables to a string. So what TypeScript is trying to tell you right now is that duration may be a string, maybe it's not. So you cannot just assume that it's a string and assign it wherever you want, right? So that's why it prevents you from actually assigning this variable to some other variables that you know. So if I want to assign duration to this string variable, what I can do is basically convert it to a string, and then I'm pretty sure that this will always be a string. A nice way to do this is to use the template literals, and this will work perfectly fine. So now this is a part of the string and it will always be a string, so TypeScript doesn't complain at all. So far we've seen a bunch of wildcards that help us guard unknown values. But what if we know already that a variable can have two types? So for example, if we have an ID that can be a string or undefined. Now, don't get me wrong, this is not a good practice to follow, but occasionally you'll run into a library that expects a parameter to be a string or a number. So TypeScript allows you to have union types. Let me show you how this works. I'm back here in my editor and I will declare an ID that it can be a string or it can be undefined. This is called a union, and as you guessed, I can assign a string to this variable or I can have undefined, and it will work perfectly fine. Now, you will notice that if you try to console log this variable here, before even we assign a value, TypeScript will not complain. But if I remove this undefined from my union, TypeScript, as we've seen before, will not allow me to use a variable that is not assigned yet. So I would recommend to avoid having variables that accept multiple types. And that's how you deal with types. So let's talk about enums, because TypeScript adds support for enums in JavaScript. JavaScript doesn't have natively support for enums. They have something like symbols, which works in a similar way, but enums help. And let me show you how you can define an enum. We are building a music player, as you know, in this series. So let's imagine that all our files are stored in different file types. So we can have file types as an enum, and some of the available options, of course, will be MP3. MP3. We can have MP4, that's for video files, and we can have WAV files. Okay, that's perfect. So now if I have a const file type, I can assign file types .mp3. So use enums as much as you can in your code. It helps you reduce the typos, right? Sometimes you write this with a capital M, sometimes with a small m. So this speeds up our development even more. One thing that you should remember about enums is that they always have a default value. So for example, here the first one will have the value 0, the second one will have the value 1, and so on and so forth. If I want, I can specify these values by myself. I can use a string or a number if I want. I can use the combination of those two, but I cannot use any other type. So if I have a boolean here, it will not work. Also, another important thing to remember is when you compare these types. So for example, if you say file types.mp3 smaller than file types.mp4, TypeScript actually compares their values. This means that if you have a higher number for MP3, then MP3 will be actually higher than MP4, and this will be falsy. Now let's save the file. I will launch my terminal for a minute, and what I will do is compile this file. So I'm running the TypeScript compiler to create a JS file. And let's open this file just to see what it produces. So I will go at the very bottom of this file. So if I scroll all the way down, what I can see is that this enum is actually available on runtime, right? And all these values that I specify here are being reflected in my actual JavaScript file. One small hack, if you want to override this behavior, is to use a const here. And now I'm saving again the file. Let's compile it again. Let's run the TypeScript compiler. So now, as you can see, file types has been completely removed from my JavaScript file, which means it's not anymore available on runtime. It also means that if you have large enums with a lot of information, you have less code to download. Now, of course, this enum will be still available in your TypeScript code, but it will not be available as you run the application. Congratulations! You've made it so far. I'm very proud of you. So there is one last feature I would like to show you. It's called type aliases, and it's very, very powerful. So back in the code, so let's close this guy here. And what I would like to do is create a type. So my type will be a truck, as you remember from the previous video. So basically what I did here is to combine all these variables that we've seen in the beginning of this video in one type alias, which is called truck. So basically now I can create objects. Let's say truck, which is a truck, and I can assign values to them. It was so simple. So now that I have this truck type, I can simply export it, and this will let me import it from anywhere I want inside my code. Now, I don't want really to export this type because I have only a single file, but I want to show you another cool feature about of type aliases. If I try to redefine another truck with a different set of properties, TypeScript will prevent this. And this is really cool because it can only allow a single truck, right? This is like a type definition, my own type definition, which means I don't want to have two strings, I don't want to have two numbers, I just want to have one truck. So this will not work, thankfully. Another cool thing about type aliases is that they support unions. So here, for example, you can say that this can be undefined or it can have this structure. If you want to review what we've learned, you should check my blog post about types. It contains all the examples that we've seen, and I also have some additional information to help you understand these concepts better. Did I tell you to subscribe today? I think no, but you know what? Don't subscribe. You will lose the next video. Anyway, I'm very much thank you for watching this video. See you in the next one. Have a very nice creative day.